Saxon Algebra 1, Lesson 10. You guys, you'll remember last time I was all excited because we just had one topic and I wrote it down up there. And then I got to Lesson 10 and guess what? We're back to multiple topics. So, the first topic is one of my favorites. It involves the situation of dividing by 0. Okay, let me start with something simpler. 2 times 3 equals 6. We all know that. So we can say 6 divided by 3 equals 2, or we can say 6 divided by 2 equals 3, right? You put the product on the top and then one of the factors down below, and then your answer is the other factor. But what about this problem? Okay, let's set that one aside. 6 times 0 equals 0. Anytime you multiply a number by 0, you get 0. It doesn't matter what the other number is. So, we can say this, right? 0 is the product, that goes here. 6 is one of the factors, and that will give us the other one. We can say 0 is the product and then divide it by the other 0. That just equals 0. It doesn't equal 1. It equals 0. That's kind of okay. But in no time can we ever say 6 divided by 0, because 6 will never be a product with 0, one of the factors. If this isn't making sense to you, don't worry about it. Just trust me. We can never have 0 in the bottom. They're okay on top. And I'm saying on the bottom, I mean the denominator. But you know what? Sometimes things stick in your head better if you use simple words. This doesn't work. It is undefined. It is indeterminate. Those are 2 math words. Let's write those down. Undefined or, what did I say? Indeterminate. It means you can't have it. And here's what I want to ask you to do. You guys probably don't remember this, but once upon a time, there was a building called the Kingdom. And when they decided they wanted to build what we now call CenturyLink Field and T-Mobile Park, they had to blow up the Kingdom in order to clear the space, because this was built in the space where those 2 parks are now. Okay, so what they did was they blow it up. They blew it up. That's what happens in my mind if we try to divide by 0. The universe implodes and it would look just like the Kingdom coming down. So what I want you to do is I want you to go on YouTube or wherever and Google search Kingdom implosion. I'm not kidding. I really want you to do this, and I want you to just look at it. There are some videos that are a couple minutes long, but you can get some, 20-seconders that will get right to the good stuff. I want you to see that Kingdom implode. Watch it 5 times, because you know what? Every time I watch it, I always have to watch it like 5 times because it's so cool. There's one that's longer that shows them setting the charges all along here. It's amazing. Like, you can see all the explosions going off along these ribs. I love it. I love a good explosion. But I want you to watch that, and I want you to think about how that is essentially what we're saying happens if you try to divide by 0. It's mass chaos, you guys. You can't do it. So watch the Kingdom implosion, and remember, you can't divide by 0. Okay, what does this look like in a problem? Let's see. All right, evaluate A. John's doing this cheating A and B thing again, which just kills me. Okay, so we're supposed to simplify this. All right, 4 minus 2 is 2, minus 2 more is 0. Okay, that's fine. Zeros in the numerator are fine. They're just equal to 0. The denominator has no meaning, right? Because if you don't have any pizza, it doesn't matter how many pieces it used to be cut in. They're all gone, and all you have left is 0. That's cool. Now let's try another one. $13 is on the top now, and oh, look at that. I ruined the problem. 4 minus 2 minus 2 is on the bottom, 0. Uh-oh, there goes the kingdom. No, it can't be. So we don't have the happy little answer of 0. We write undefined, or we write indeterminate, which means there's no such answer, it can't be determined. That is what we say, okay? It doesn't have any, this has no value at all. It's a nonsensical problem. Okay, I'm done talking about that. We're now ready to talk about, I don't like John's name for it. Let me just show you the problem. John makes an easy thing sound hard sometimes, and I don't even want to put it in your head. The instructions say, find the product, and this is what we're given. Okay, so what's happening here is we are multiplying all 4 of those factors together. Yeah, there's some minus signs, we'll get to those. But first I want to talk about how you can pick and choose what order you want to multiply in. So when I look at this, let's just say I decided to work it from this side to this side. 2 times 6 is 12. 12 times 3 is 36, but then 36 times 4, I can't do that in my head. I don't know the answer to that. What if I instead chose to do it this way? What if I decided to go 4 times 3 is 12. 12 times 6, if you know your 12 times tables, you're in luck. It's 72. And then, so that gets us to 72 times 2. Well, multiplying by 2 is just doubling, so I can do that pretty easily too. And then we have 1, 2, 3 minus signs. Every 2 go together to make a positive, so it ends up being minus 144. The point of this is, feel free to mix up the order of the multiplications to make it easier for you. Here's another one. These are the same numbers. How is that harder? I don't know. I'll just write it down. We'll see if we can figure it out. Oh. Here's another way you could look at it. I don't know if this was John's point, but 6 times 2 is 12. So that's 1. It would be positive, right? And then these 2 make another 12 that are negative. And if you know your 12 times, you know that's 144, and it would be minus because there's just 1. So play around, look for the easiest pattern. Now they're doing another one. John's doing another one. He's really flogging this dead horse here. Okay, in this one, let's say, here we did it like that and like that. This one, maybe you could do positive 24. You could do them in order, times minus 6, but I don't know that right off the top of my head. I like these ones better because I can figure them out really quickly. I don't want to do it this way because I have to go over here and go 24 times 6. That's 24, that's 2, that's 12. Oh, look, it happened to turn out the same way. That's a shock. But the point is, do it whatever way works best for your head. End of story. Last topic. Conversions of areas. Okay, we've talked about using unit multipliers to convert units of measure, say from inches to miles or feet to meters, right? Okay, so we've done length conversions. And they involve things like I just said, inches, feet, yards, miles, and then over in the metric world, we can do centimeters, meters, kilometers. Those are the ones we've been using the most, okay? That's cool. These are lengths, and they are measures in one dimension, right? It's like converting the length of a piece of string or a line. Now we're doing what are called area conversions. And instead of it being like a piece of string, these are like fabric, right? They have two dimensions. They have a length and a width. And so we'll use these same measures, but it will be inches squared, feet squared, yards squared, miles squared, because when we find an area, we multiply the length times the width, and that's where we get the squaring, because it would be like 5 inches by 6 inches. So it would be inches squared. And same for metric. Okay, so the way we do the conversions for area is a titch different than the way we do the conversions of length. And I will show you in an example. Use 2 unit multipliers. John gives us hints, and that is really nice of him. To convert 44 square inches. So what I'm gonna write over here is 44, and then I'm gonna write, instead of writing inches squared like that, I'm gonna make an abbreviation for inches, and I'm gonna write it twice instead of the square. I have a method to my madness, stick with me. And we wanna convert it to square centimeters. And I'm gonna write those on top of each other because I didn't leave myself enough room, but write that twice too instead of writing it squared. Now, John told us that we need to use 2 unit multipliers. So I'm gonna draw the boxes. And I'm gonna use these to come up with what we call unit multipliers, some fractions that are equal to 1, but have the 2 different units in them, that connect the 2 units. Okay, what's the relationship between inches and centimeters? Okay, we know that for 1 inch, there are 2.54 centimeters. And we know we're gonna put that information in the box because those are equal. Let me just put equal signs, that's clearer. So we're gonna write one of these on the top and one on the bottom. We have to figure out which. The rule is that we always put starting unit on the bottom. Denominator. To be technically correct, but again, I'm trying to speak to your head and not your mathematical, theoretical brain. We're starting in inches, so that means we want inches on the bottom. For 1 inch, there are 2.54 centimeters. But because we're talking about area, which is a square, we have to adjust it twice. And here's the way you can imagine that. Here's our little piece of paper. It's 1 square inch. That's technically too big, isn't it? And originally we had it as 1 and 1. Let's pretend it's not 44. When we convert this to centimeters, we have to change this dimension. You just write this out. Instead of 1 inch, we're saying that's 2.54 centimeters, but we have to do it twice because we have to convert both sides of the shape. So we have to use the multiplier twice to do both dimensions. Right? This is 2-dimensional. We only had to do 1 before because it was 1-dimensional. Okay, so it's no harder. We just have to remember, oh, because we're working in area, which is 2-dimensional, we have to do it twice. And then our answer is just going to be, again, we don't have to multiply it through. It's going to be 44 times 2.54, and I'm squishing, times 2.54 centimeters squared. Oh, I forgot to cancel my units. There are all the numbers. Now, when we use one conversion factor, we get to cancel one of the inches. but we have to cancel both of them, and that reminds us, oh yeah, you have to use 2. Canceling the units is the best way you can catch any mistakes and make sure that the design of your equation is going to work out. That left us with centimeters on the top, and that's exactly what we wanted. So my final answer, if I was going to write it neatly, 44 times 2.54 times 2.54 centimeters squared. I could write this with parentheses if I didn't want to use the dots. And that's how John usually writes his answers. Okay? So that's what makes an area conversion different than a length conversion. We have to convert 2 dimensions, so we use the multiplier twice. One more problem, and then we're done and you get to do the homework. Oh, I'm so jealous. That wasn't very nice of me. I didn't appreciate doing my algebra homework when I was your age. You know what my biggest grievance was? I went to traditional school, so we didn't have textbooks at home. So we would start the assignment in class, and then if you didn't finish it, we'd always have time at the end of class to start. If you didn't finish it, you had to take your book home to see what the problems were. I don't want to care. We didn't have backpacks in those days, you guys. I mean, there were dinosaurs roaming the earth. We didn't have backpacks. Backpacks started when I was in college, but I didn't have them in high school. I did not want to carry my math textbook home just to do, 8 or 10 dumb problems. So what I would always do when we were given time in class to get started on our homework, I would start by copying all the problems down on a piece of paper, front and back usually. Then I would start working them with the time I had, and sometimes I would finish. But if I had more to do, then all I had to do was take the piece of paper out of my notebook, fold it up, put it in my back pocket, and carry it home like that. Then when I got home, I'd just have the piece of paper and there were all the problems. So, I was just outwitting the system ever since those days. I don't know what I'm talking about, but you know what I'm talking about. Homework can be a drag. I didn't have the answers either, so you'd always do the problems and just be like, oh well, I hope it works out. Okay, problem 10.6. Use 4 unit multipliers to convert 125 square centimeters. So again, instead of using a little exponent, I'm gonna write it twice. I'm gonna stack it to save myself a little bit of room this way, because John said we need 4 unit multipliers. That's kind of a lot. And then we want to get it to feet. So I'll put the feet down here. Now I'm going to draw 4 boxes, and I'm going to just do it the easy way. Draw 1 big box and divide it up. All right, we have to go from centimeters to feet. All right, how are we going to do that? Well, centimeters, I need to switch to English units, and the only way to do that is to go from centimeters to inches and then inches to feet. So that's what we're going to do. Centimeters to inches will be the first 2 boxes because it's an area measurement in 2 dimensions, so we need to do it twice. Then we'll have it in inches, and we need to go from inches to feet. So there's my plan of how I'm going to use those 4 multipliers. Thank you, John, for giving me the heads up that it would take 4. And now I know why. Okay, so the first one, here we go. I'm not going to write them separately down below like we used to do. We're past that. Starting unit in the bottom. So that's going to go there. That means inches are going to go up here. What's bigger, an inch or a centimeter? That's the first question I ask myself when I'm trying to get to the numbers. Inches are bigger, and then I go, oh yeah, 2.54 centimeters. Let's check and see if that cancels the way we want it to. Yes, hallelujah. Now we're in inches. That's where we want to be. We want to go from inches to feet. Starting unit in the bottom. Once we cancel and have it, this is like our new starting unit. That means we'll have feet up here. What's bigger, an inch or a foot? A foot is bigger. 12 inches in a foot. Remember, if you don't know these, you should write them back here. If you don't have them memorized, and there's no shame in that. If you can't remember how many inches are in a foot, just write it down. If there are any relationships like that you can't remember right off the top of your head, like you don't know how many feet are in a mile, let's say you can't remember, you can dig around in the book, you can dig around in the notes, or just Google it, you guys. It's not that hard, it's easy to find. So track those relationships down, and if you don't know them, write them down, and you'll eventually memorize them. Okay, so now our inches are canceling, right? Top and bottom. We're left with feet squared, and look, that's exactly what we want. That's what we want our answer to be. Okay, good. These are crowded enough that I don't even try to smush my number down there. I'm gonna put this over a 1 so that it all makes sense. Remember, we're multiplying all of this together. That's why we call them unit multipliers, because we're multiplying. And I'm gonna ignore the 1s because 1 is not a meaningful factor for multiplication. I can ignore it. So I'm gonna write 125 over 2.54 times 2.54 times 12 times 12 feet squared. I'm presenting that as my final answer, which is correct. Another way we could write this that is equally correct is to use an exponent to simplify the fact that we're multiplying twice 2.54 and twice 12. Okay, so this is also perfectly valid. Do it whichever way you like. If you use the exponents and John doesn't, just check to make sure that it all is turning out properly. All right, that's the end of lesson 10. It did have multiple topics, but it wasn't too disgustingly long. Yay, we're moving into a brighter day of not quite so much review, and the lessons move along a little more crisply. We're still reviewing though, so don't think like that this is supposed to be new and you're in the wrong class. It'll be another couple weeks of review before we really get everything under our belts, okay? All right, I'm done. Good luck with your homework, and I will see you next time.